So we will learn about units today. So to understand unit, we need to understand physical quantity, right? To understand unit, it is very necessary to understand what is physical quantity. So in our daily life, we see variety of objects around us. It can be anything: a laptop, a table, a chair, a bag, right? A bag of rice, a bag of potato, anything. So sometimes in our daily life it becomes necessary to measure quantities of those objects. For what? To get the information about the amount of these quantities. Like what? Like in your daily life, when you go to market, you have to know how much quantity of rice you need to buy, or how much kg of rice you need to buy, or how much kg of potato you need to buy. So that's why you are measuring, right? You need to know the mass of the amount of rice or anything else. In another example, you can think about a height of a person. Sometimes we ask each other that how tall are you? So you need to know the height of that person, right? So the definition of the physical quantity would be any physical property that can be quantified and can be measured using numbers is called physical quantity, right? So what will be the example of physical quantities? Length of something, mass of an object, time, area, etc., etc. Why? Because these are all physical properties that can be assigned a numerical value, which we are talking about quantifying something. Quantifying means we can assign a numerical value to these properties. Like 5 kg of rice, we can assign a numerical value, right? It means 5 times of 1 kg. If you put 1 kg of rice 5 times, it will be 5 kg. So you can assign a numerical value to these properties. That means these are physical quantity, right? Now, as we have learned what is physical quantity, we have to learn another thing, like types of physical quantity. So there are two types of physical quantities. one is scalar and another is vector, right? So what are these quantities, two types of quantities? Why we have to separate these two quantities? So in case of scalar, scalar are those physical quantities, scalar are those physical quantities that only has a magnitude but no directions, or it doesn't require any direction to be assigned to it. It simply means it doesn't need any direction assigned to it. To define it, only magnitude is sufficient. To define a scalar value, only magnitude is sufficient. Like what? What can be the example? Like length, mass, volume, density, work, power, energy, temperature, frequency, right? So if you think about these, length means how much long something is, right? How much long the distance is. So you only need the length, the measurement, the magnitude value. You don't need the direction. There is no need of direction. Mass means how much amount of material is in an object. So it also doesn't need any direction. Volume means how much space an object is what can we say it, how much space an object is acquiring. If you put an object in here, so its volume will make you understand that how big that object is, right? So these are all attributes of an object we can understand. Now, so what we learned is that length tells us the how much long the distance is, mass tells us the amount of materials in an object, volume tells us how much space an object will occupy, right? Like how big the object is, and density will tell us how dense an object is, means how much particles are found in an unit volume. How much particle are found in an unit volume. So if it is a very dense particle, if it is a very dense object, we will find many particles in unit volume, right? Like how dense a object is will be defined by its density. So from these definitions you can understand that you don't need to assign any kind of direction to these physical quantities, right? These are scalar quantities. So you guys will learn about these scalar and vector quantities through scalar and vector products in class 11, Okay, so in class 9 you only need to know the overview, right? So now we will talk about the vector quantities. So in case of vector quantities, these are those physical quantities which consists of both magnitude and directions, right? So the examples would be forces, displacement, acceleration, velocity, etc., etc., right? So when we talk about a force, what we say, that this is an object and we are applying a force this way. So you can see that when you are talking about a force, the force always act in a particular direction. So only magnitude or how powerful the force is won't define the force totally. We will also assign a direction in which the force is acting, right? Like the force is acting in north direction or the force is acting in northeast direction, right? So in case of defining a force we need both magnitude and a direction, right? Similarly, in case of displacement, what is the definition of displacement? What is the definition of displacement? The definition of displacement is the change in position of an object, right? So let's assume that the object is here at 0 second. So after 1 second the object travels here. So the displacement does not measures this distance. This is the distance, right? The length. So when we will measure the length, we only need the magnitude, how long the distance is. So that is the scalar quantity. In case of displacement, we will measure the change in the position. So here the previous initial position was at this point. After 1 second the position is changed at this point. So the change in position is the distance between the previous position and the final position. So the displacement is in this direction. So to understand the displacement or the change in position of an object, we also need to know the direction in which the position has changed. So that's why displacement is a vector quantity, because we need to define the change in position. To define the change in position, you need to mention the direction. So that's why this is a vector quantity, right? Thank you guys, this is for today. So next day we will talk about units and its definition, CGS and SI unit systems, and some other rules to write an unit. Okay, thank you, bye.